Alright, this is day 14 of doing math problems until a Hololive member notices me. So, here we have a system of equations that we have to find x and y. So, naturally, we are taught to, isolate one variable or quote unquote eliminate a variable. But here we're not going to simply isolate a variable because that will pretty much rack up in degree, which will be a hassle to solve. And looking at the left side for both equations, they look very similar. It's just that everything is squared in the second equation, and in the first equation, everything is there. So let's just say that we have, for example, right? I could square this, which I'm not going to yet, but let's just look at x plus y plus root xy, right? Here, what I'm going to do, right, is set x plus y equal to a and the square root of xy equal to b. Okay? And pretty much this is going to lead us to have the first or the second equation being a plus b is equal to 3. Right? And the second equation is going to be a bit tricky, but the fact that we are setting x plus y equal to a is going to help us with the squares. So if we square a, we will have a squared is equal to x squared plus 2xy plus y squared. And if we subtract 2xy, we will have a squared minus 2xy is equal to x squared plus y squared. And we know that xy is b squared, so we could write this as b squared, right? So we have a squared, and then we have minus b squared plus b squared is equal to, since we have it is equal to 4, we'll just leave that as 4. Okay? This is pretty much going to help us a lot because actually, hold on a minute. There was just a small mistake that I made. It is 2b squared. So, after all that, we see that pretty much we have our system of equations in terms of a, b, and that's it. And here we could simply have a very nice system of equations, which is really going to be very nice for us. Because for our second equation in terms of a squared minus b squared, we could write this as a difference of squares. So we have a minus b times a plus b is equal to 4. And we know that a minus b is going to be equal to 4 over 3 because ab is 4 over 3. So now we are just tasked with solving for a plus b equals 3, and a minus b is equal to 4 over 3. And solving for a, right, we have 2a is equal to 3 plus 4 over 3, which is going to be 9 plus 4, which is 13 over 4, or actually over 3. And dividing by 2, a is equal to 13 over 6. So we know that a is 6 over 13. And we're going to solve for b as well. And we're going to subtract the second equation, so we will have 2b is equal to 3 minus 4 over 3, which is going to be 5 over 3, where b is equal to 5 over 6. Okay? So the fact that we found A and B is going to make our life much easier now. And now we simply have to solve a basic system of equations, which is x plus y is equal to 13 over 6, and xy is equal to 25 over 36. And solving for either x or y is just a question of solving a quadratic in terms of one variable, which will give us, let's solve for, let's say, x. So x is equal to 25 over 36y. Plugging that into the first equation, x plus y, we will have that we have 25 over 36 plus y squared is equal to 13 over 6y. And we have y squared minus 13 over 6y plus 25 over 36 is equal to 0. Okay? So here we're just going to go ahead and use the quadratic formula because we love it so much. So, right, we'll have y is equal to 13 over 6 plus or minus the square root of 13 squared, which is 169 over 36, minus 100 over 36. Okay. And it is all over 2. This gives us 13 over 6 plus or minus the square root of 69 over 36 all over 2, which I will just pretty much write this as 69 over 6 all over 2. And y is equal to 13 over 12 plus or minus the square root of 69 over 12. So pretty much this wasn't that bad, right? And what we have to do now to find x is simply just plug in y. Okay? So let's go ahead and do that. So x is equal to 25 over 36 times 13 over 12 plus, let's just use the positive value for this. So we'll have 69 over 12, right? And pretty much 25 over 36 times all of that. We would pretty much have to multiply by the reciprocal of the denominator because of the fact that we have the entire square root, and that pretty much makes it a bit harder for us to deal with that kind of stuff. But the beautiful thing is that pretty much x and y are related, so it doesn't matter what we choose for x and y because x and y always lead to the same quadratic. Meaning that if y is positive, then x is simply going to be just the negative version of it. 13 over 12 minus root 69 over 12. So pretty much if y is positive, right, then that tells us x is going to be negative because of the fact that it's in the denominator. So pretty much we found x and y already, which is very nice, but verifying our solutions is going to be a pain. So what I will say is that I will not verify my solutions because it is a pain. Well, not really, right? Because we could simply do a bit of trickery and we have xy is just going to be 25 over 36 because these will cancel out, and x plus y, the square roots will cancel out, and we will have 26 over 12, and you get the point, right? It's still going to give us a solution to our system of equations, but for the sake of it, we're just going to go ahead and verify that it satisfies the first equation. So we will have 13 over 12 minus root 69 over 12 plus the square root, right, of all this, which I'll just write as 25 over 36, which is just 5 over 6, plus 13 over 12 plus the square root of 69 over 12. They cancel out. And then here we have 13 plus 13, which is 26. And then we have plus 5 or plus 10 over 6. And after that, we will have actually not 6 over 12 is equal to 36 over 12, and that is equal to 3. So woohoo, look at that. We have that our solution for x and y are true. And I will not verify the second equation because it's going to hold because of the fact that we use both equations to get an answer. So yeah, that's pretty much that for this seemingly innocent system of equations, and hopefully you guys learned something from this. And yeah, have a fun day, and bye-bye.